Welcome to Session 4, the BBC Microbit. Next Steps with Aldrin Torres and Marty Stone, Hacemos Atlanta volunteers.
About Python. So what is Python? Python is a programming language that is widely used since the 1990s, long time ago. It's a very easy programming languages. It's a text-based coding. It's a very natural English structure, so you can learn easily. It's so easy that they are starting these coding lines in schools. This can be very powerful that now that teachers are eager to teach their students at their schools and adding more things fun. Microbit.org has an option to do that on their website. So you see there's a link, you go on the top and you see Let's Code, and it shows you to this website. You can code in different versions. Have you practiced with those is the make code editor. But now we're going to move to the Python editor. So let's talk more about Python before we go to in deep detail. So as we said, it's a programming language. It's an easy to work with language. You can accomplish more stuff, more tasks with less code lines. That was one of the beauty of Python. There are other coding languages that are older than Python. It could be C, Perl, Java, C++, and other ones that are being behind. C and other languages are mainly used for assembly line or working with hardware. But Python is becoming more and more sophisticated, but gradually will take over on the industry. It's right now being used to read from a website or processing text or data like JSON or crunching numbers. I mean by math, making math, creating charts. Is a faster programming language with less hassle. It's also very powerful, as I said. It's being used by the industry. YouTube is using it. Google and Dropbox, where you put your files online. Raspberry Pi is another small computer that you will see in the future. I remember Netflix is using us as well, one of those companies that stream videos. Those companies use Python for automation. That includes also machine learning, management, and other stuff that are very cheeky and geek ways that you can do. So if you go and pursue an engineer career, you should maybe using Python right now to learn and move forward to your computer science career, if that is the case. And even if you don't want to, it would be very useful for other careers like doctors and accountants and teachers and medical staff. All people who make charts will use Python at some point or might use the final product of Python software. There are also a lot of libraries. Those libraries are powerful to add all other type of stuff that you want to do into it. Just consider libraries as an extra tool you add into your car. For example, you want a fancy rooftop on your car, then just have this additional library or package. All right, so let's go one more thing about Python, and it's about who invented Python. And Python was invented by Guido van Rossum. The name sounds funny, but he's from the Netherlands. He's a Dutch programmer back in the 1991. And he named Python based on a television show, a European television show called Monty Python Flying Circus. That's why the name came from.
Well, you can use the
All
Python
right?
editor provided
So
in the
if you're ready
microbit
to
online
Google more
website.
about Python, you can
There
do
is
it on your
also a
own. Take
Python
look
editor
at more
that
information
you can
on what is
get
powerful
that you
to
can
do.
use on your
Then you
home
will see in the
computer
next video
that you don't
about
have to be online for, and it's
coding
called Mu
our
or
first
MU Python.
Python code
So all you have to do is do a search for MU Python. Code with Mu. It's a simple Python editor for beginners and programmers. So let's go to their site. And here you see an example of coding with the Mu coding editor, Python editor. And we're going to go ahead and all you have to do is click download. In this case, I'm using Windows. So I'm going to click for the Windows installer 64-bit. I'm going to save the file. Once the file is saved, which it's done, I'm going to go ahead and install the Mu editor and coder. All right. I'm going to say yes, I want to install it. I'm going to click next. I'll agree. Anyone using the computer, even though that's just me. And I'm going to install it again. We'll install it. So while this is happening, we'll go ahead and pause the video and we'll get back as soon as it's done installing. All right, well, the Mu editor and compiler has been installed, so I'm going to go ahead and click Finish. Let's see if we can find it on my computer. And there it is. So we'll go ahead and start the Mu editor. All right. So it says here, please select the desired mode and then click OK. Well, there's a whole bunch of different things that are available from you. There's the Adafruit Circuit Python, there's the BBC Microbit, there's the Pygame 0, and also Python 3. In this case, we're working with the BBC Microbit, so we'll select that and say OK. And this is supported by the Raspberry Pi and the Microbit Foundation. Alright, so here is our editor, and it's very much like the online editor. You can change the mode. Again, you can change it from different platforms, but we're okay with this. This would be for a new program. This would be to load a Python script. This would be to save a Python script. Loading a Python script means getting a Python script you've already written and pulling it into your editor. Saving one is saving the current Python script you have. Flashing will take your script and turn it into code for your microbit. This right here will access the files, the system files on your microbit. This right here is to do live code on the microbit. This is just microbit one line at a time. This is a really cool feature that we'll be showing you later, is how to plot your data. This is just zooming in and zooming out. Of course, you can change the theme, make it night or day. This is checking your code to make sure it's okay. This is a help function, and this is to quit Mu. And that pretty much is an overview of getting the getting the Python Mu editor and compiler.
Of microBit. In this case, I hope you learn how to use a compiler editor with microPython and microBit. Today we're going to show the rock, paper, scissors game that we did with a make code with a block section, but now we're going to use the microPython programming language. Okay, so I have plugged my device. You see the power cable is connected to my computer, but in this case, let's review one simple thing that we need to do. Any microbit will have a software, which is the code that you load, and a firmware is the version of the compiler that has to be adapted to your microbit. So let's check that first. So I'll go to this website and I'll have it here. And I'll go to the microbit update firmware. So I'll make sure I have the latest one. So you have to go and check on your device. You can go on your Windows machine, go to your microbit USB port. I have it here. And I go to the details. And if you see, I have the latest version 253. Let's say I have an older version and a number below 253, and I just go there and disconnect my microbit. I plug the reset button. I keep it pressed, and then I plug it here. on my microbit. I release, and now it blinks. And if I look at my microbit, now I will have it as maintenance. So you download the software. Let's see where I put it here. Is this one? This is the newer version. What I do is just move it to maintenance. After it's complete, what happened? It will reset and it will appear my microbit as my new port as microbit. So it will be updated to the latest version. All right, very good. Now that we have passed that phase, let's start coding. All right, so we have to go to our microbit editor. So just click and look for Python editor. Now it's running. So make sure your USB cable is connected. There's a lot of things we can do. A difference with the make code, there's no way to simulate the device on your screen, but we have this powerful option, which is Open Serial, that we need to work on. So let's connect first the device. Let's connect. So it prompts a window like this, and it's looking for something to pair. So right now I have microbit on my computer, and I'll say connect. Now my device is connected. After it's connected, I have the Open Serial. This Open Serial will let us know on text what's going on with the microbit and if we have problems or not. Right now we don't have nothing, so we're good to go. All right, close the serial and back to my screen. This is the original screen, so I will remove this one and start from scratch. If you see, this example is only to say hello world on your microbit. Okay, let's see. I will download that code. I just click to download the code is to flash it to your microbit, so I'll do it right now. Let's see what it is. It's flashing. You see it's blinking. And now it says something hello world. All right, so that code works. If you see it says hello world screening, and then the second line, if you see in the screen, will be show the heart. So you show the heart after hello world finished. There you go. And sleep for 2 seconds and start over again. All right. So let's do our rock, paper, scissors with this tool. There are 2 ways to review what functions and what information when you start coding in microPython. One is to look for this website, which is microbit-micropython.read.docs.io, and you will see all the different functions that you might use. If you remember in our previous lessons, we have discussed about input and output. So you have this here that you can review on your own, and it will tell you some samples about how to code. And if you remember for the make code section, what we need for the rock, paper, scissors. Yes, we need the accelerometer to shake it, right? And random numbers. So we have these 2 functions to use, random. And remember, the random is a number selected from 1 to 3 or 0 to 2. Remember, 0 is a number, so we can play with those 3 different variables. 0 could be paper, 1 could be rock, and 2 could be scissors, okay? We can play with those random number selections, just like in the make code. All right. And we talk about random, and we have the accelerometer. Let's look for the accelerometer. All right. Here it is. Okay. We can do the same with the microPython serial command. So I'll go open serial, and I type here. It will pop something. If not, I'll click send Ctrl+C. All right. So I have some command language here. So I'll click help, as you see in the screen. Help. And it tells me what to do. So one thing I can do is help the modules. All right, so remember, accelerometer and random are our modules to review. So let's try help, random. See that works? Oh, close parenthesis, there we go. Oh, there's nothing into it. Let me go there, random. Let's see if that's correct. All right, there's nothing into it, so I'll try it again. Help, function, so help. There you go. So we should get something after this. So let me see there, here. All right. So these are the sections. Let me see if I can. I'm just blocking with my screen, but I will find the accelerometer, which is here. So there, accelerometer. And you can find all the different functions beside these models, right, that we can use. All right, so to make it easier, let's go to the accelerometer here. We'll look for all these different functions that we need. We don't need to get the coordinates. You can read on your own, but we don't need this. What we need here is to get some random numbers. So I'll get yesterday. Microbit accelerometer was yesterday. That's one function that we use. All right, let's start coding our microbit. There we go. Put here a little bit up so we can see. I will close the serial. I will remove this part. We don't need this. Remember that while true is our forever loop. There we go. Let's start. So I will do if accelerometer, my section here, was yesterday, was what happened in the previous second that it checked the value of the accelerometer when we were shaking it. So we can stop it and see what is the result. All right, let's start again. Accelerometer was yesterday. And from here, we'll see what is the value. So what value we can use with this? So the values that you can put under the parentheses, this name could be any of those. So if it's a shake, I'll look for shake. All right, we have the shake option. So let's put it here, shake. Let me see if this works. Shake, there we go. All right, and semicolon, because there's something that if we shake, we will have to do something. All right, so let's put it here, tool. I can call it name, tool, or hand, whatever you want to call it. I will just call it tool for now. It's random, rand int. So this option, if we go here, we'll go through a random. I select random int. And the idea is because we're looking for an integer. An integer is a value of a number, right? That was looking for. Let's see what other random options we have for this module. And we can get random integer or a string, which could be a text or a word that we can add in. Right now we're looking for a number, not a word, so we're gonna word random int. And what will be the value in between? So random int will have to be in parentheses, and it should be two numbers, the first and the last one. So let's do that one. So random int between 1 to 3. Let's see if that works. So it's 1 will be rock, 2 will be paper, and 3 will be scissors. Okay. So let's do that. So random int. Let's see what we have to do if something happens. So tool equal random int. So that's a random number that we selected. So if tool equals to 0, let's see what we're gonna do. Semicolon. If you see, when we do I click enter, you go to a tab. So make sure we keep this tab there. This is very important. So we know that if this sequence goes inside this if. So if we tool, let's do a display. So we want to do on display. Let's see why display is important. So let's go for the module display. Oh, here's one of display. So we want to display some images. It's here. We can display pixels. We can clear the screen. We can show something. In this case, to make it easier, we're gonna show an image already defined in the microPython modules. All right, so I'll do microbit display show. Let's go, display show, and then I'll do what image. So how I call the image. Let's go to see how I call an image. So look for the image that we can display. So I'll go for the image section. There we go. And this is more or less how you display an image. But this is where you want to do it using the LED. So I will skip this part. There should be some already defined image. All right, these are the attributes of the image. They'll have heart small, happy, small. You can select all of those. For me, I will do the simple square. Square will represent the rock, and square will represent the paper, and square small will represent the rock. So let's do that. Let me see if I can find scissors. If not, we want to create our own scissors. All right, there we go. So I'll put image dot square. That will be my rock small. Did we do it right? Square square small, all right, everything uppercase. It's very important to keep the uppercase and lowercase in our microbit, all right? Let's do the next part. So move back one up, if tool equals 1. Let's see what happens if it's 1. Then we're gonna do display the next part, image square, all right? Very good. So we have 2. Last and not least, so it will be else tool equal. We don't need that one, just only say else because that's the last part. So you just need to type else, and then we'll see display show. And I will do, let's say for now, let's see what we can pick as an image. I can do a butterfly. Let's do a butterfly for now, since we don't have scissor. Or something short. I will do school. I'll do school. That's a shorter word to type. There we go. And I think we're ready with our code. Let's see if that works. Let's see if we don't have any errors on our code. And maybe I need to import random function. Let me see if I can add it here. Import random. Just to make sure that we have the random function included into this. And let's see. Let's start again. Open serial. All right, let's do flash it. Let's see that works. Flashing is loading on my microbit. All right, let me shake it. All right, I got a school. It's working. I shake it. Oh, it's that's the bigger square. That will be paper. Shake it. That's a school. I shake it. 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 All right, shake it. I shake it. I shake it. All right. I'm not getting the square small, so something is wrong with my code. I see what I did on mistake. There's no random zeros, so I have to select 1 and 2 because our numbers are from 1 to 2 and 3. All right, this will work. Let me flash it again. All right, let's do it again. All right, I got a small square. All right, bigger square. I get a school. All right, one more. All right, I got all the 3 different values. Great. This is working. All right. So I want to get the scissors. So there's no scissors defined. So there's a trick to do that. You can create your own images. So let's do that from here. So we create a new module on my own. I will call it scissors. It has to be out of the while true. You will have to define everything out of your loop. So this will be your, I can do some comments. Forever loop is below this line. Okay, so I will create my own scissors. I'll click scissors equal an image. I want an image to be displayed, and open the connection so I can do anything in between. So here's the trick. You can see we see on our documentation section that you can do an image like this. So I will use this structure. Instead of calling image, I will call it scissors, and this is the function that allows you to create this. So I will use this format, okay? So I'll just put it here, image. There we go. I just copy paste to make it easier. Control C, and then I'll put it here. Control V. Voila. All right. So how make a scissors? I'll look at the first 9 means blink. It will be LED, and 0 means the LED will be off. So if you see the different, we have in this string we have 5 characters, and we have 1, 2, 3, 4, 5 lines. So 5 lines will be the lines here that represent the LEDs, and 5 characters. Each character represents the LED on the top. All right. So let's work on the scissors. So let's make a scissors using these 9s and 0s. So I'll put here 9, and then this will be great. So I'll do the other one, 9, and then I'll put this one, great, that looks good, and then the other one, 9. All right, 9. I think that will be a scissors. Let's see if that really looks like, and instead of display show image cool, I just put scissors right here. Let's see if that works. Let's try on my code. Flashing. All right, I think it loaded perfectly. All right, so let me try it. All right, look at my scissors. I did it right, so I didn't mess it up. All right, good. Scissors, rock, paper, scissors, scissors, rock, paper. Great. We finished our rock, paper, scissors in microPython. Try it on your own. See my code. Copy it on your screen or try it on your own. Change different images. Try different scissors on your own with these little options of creating your own images. Okay, so until the next video. Bye. Of microBit.
All right, everyone. Now that you've got Mu downloaded and Aldrin shown you how to code rock, paper, scissors in Python, I'm going to show you how you can use the built-in plotter that comes with Mu. So what we'll do is we're going to go to Tutorials. We're going to come on down, and here it is, Plotting Data with Mu. So programs can generate a lot of data, but this data can be plotted in a way that makes it easy to understand. All right, so the plotter was contributed to the Mu editor by Adafruit. Adafruit is a wonderful place to go online to learn about electronics and also to get electronic parts. Anyways, the output from the plotter is in the form of a line chart. To activate the plotter, you simply have to toggle it with the plotter button, and I'll show you how to do that. Now, when the plotter is active, it begins to listen for valid sources of data. A valid source of data in this case is any group of numeric numbers that are within parentheses. This is called a tuple, a T-U-P-L-E. So in order for this to work, in order for us to plot our data, we must make sure it begins with an open parentheses and ends with a closed parentheses. All right, so let's take a look at the code. All right, I've already written this code, but I'll go through it with you. So the first thing is we have to import the microbit. If we click on mode, you can see that we're working with the BBC microbit here. And as such, we need to import the microbit, which allows us to use all of the inbuilt functions in the microbit code. The next statement says while true. Well, in this case, true is always true, so this code is going to run like a loop. It would be like the forever loop in your make code blocks editor. What do we want to do? We want to print, and the first thing we're going to print is an open parentheses, followed by the microbit temperature, followed by the closed parentheses. And then we want to sleep for 1/4 of a second, or 250 microseconds. And this allows the system to sort of catch up. The sleep function is very important here. If we actually go back and look, it talks here how important it is to have a short pause somewhere in your loop for the plotter to work correctly. The thing about computers is they run amazingly fast. And so for us humans, we have to slow them down, and that involves the sleep command. All right, so let's go back to our code. Again, we're importing the microbit. That's all the functions and features that are embedded in the microbit's code and the code available in Python. We're saying while true, which gives us a forever loop, and then we have our code of printing the open parentheses, the temperature, and the closed parentheses. And then we're going to sleep for 250 microseconds, or 1/4 of a second. Now the temperature that we're going to be getting is in Celsius, and that is pretty much standard. That is the temperature standard. Celsius is what's used by scientists all over the world. We can, later on, if you'd like, convert that into Fahrenheit, but for right now, we're going to work with Celsius. So what are we going to do? Well, we're going to save our program, make sure we save our code. The next thing we're going to do is we want to make sure that our microbit is connected to our computer. If I look here in my files, we will see, yes, in fact, I have a microbit connected to my computer. By just clicking the flash, that will actually send the code to our microbit. And it only takes just a second or two. It's very, very fast. At this point, we can go ahead and click on the plotter. and we can see the data already showing up. We can also click on REPL, and that'll show us the actual values of the temperature. But that's also what's showing up here on the plotter. Now what I'm going to do is I'm going to take the microbit, and this is basically the air temperature in our house is 22 degrees Celsius. I'm going to go ahead and put my thumb on the large chip, the microprocessor chip on my microbit, and you're going to see the temperature almost immediately go up, and there it is. And not only is the temperature going up on the right side of the board under REPL, you can also see that the BBC microbit plotter, the chart is also going up as well. Pretty cool. So as long as I keep my finger on there, right, the temperature will go up. It's going to take some time for it to get really, really hot. There are a lot of different things I could do. I could I could get something really hot and hold it up against this, and that would make the temperature shoot up really, really fast. I don't have anything in my room right now to do that, so we'll just have to rely on me using my finger. We're going to go ahead and let the temperature hopefully maybe get up 1 more degree. I don't know. We'll see. 1 more degree Celsius. It's about a couple of degrees Fahrenheit. Looks like it's going to stay right around 30. So what we saw is a temperature rise from 22 degrees Celsius to 30 degrees Celsius. That's a fair amount of temperature rise. Now if I take my finger off, it will take a little bit of time, but the temperature on the microbit will eventually go back to normal, to what it's down to 22. It will take some time to do that, but as you can see, now the temperature is coming down. So this is a pretty cool and easy way to actually plot data from your BBC microbit. You can plot accelerometer data, you can plot temperature data. We wrote that program that detects light. You can plot light data. There is all kinds of data that you can create a line chart from using your BBC microbit. And it's very simple and easy to do. Look how simple this code is. Again, import microbit. Pull in all of the code libraries available in Python for your microbit. Set up a forever loop while true. Then just print your data and sleep for a little bit of time. And it just keeps doing this over and over and over again. And so there you have it. A simple and easy way to gather data and plot it using the BBC microbit and your MU editor encoder.
Guys, we have done a lot with the little microbit device that we have here. In this session, we'll learn how to use microPython in your microbit. As you know, Python is very powerful. It can be used in the enterprise. And if you learn it now, you're able to get a job pretty soon or create your own job in the near future. So think about that. We also learned the Python editor and compiler, how to use that, how to access online. We also learned how to code a small game called Rock, Paper, Scissors in 2 different formats, the block editor and also the microPython. And we also learned how to use the serial output and plotter using the microbit under Martin Stone's lead. Yes, so there are plenty of tools that you can use. We show a little bit of you can use on your own. Make sure you surf around the website that we have here. It's the microbit, and you can get started. There's a lot of tons of games that you can play or create on your own. There's tons of information. You want to see the videos and all the things that you can read. There's a lot of lessons you can take on your own on Python and also on MakeCode. There's plenty of things you want to approach. So take your time, find things that you can do, add more stuff or gadgets into your microbit. So it's up to you to play with it. Just for advice, play at least 30 minutes every day with your microbit. Learn something new with microbit. One thing you can learn every day with your microbit is progress to your success. Until next section, bye bye.